All right, so today's lecture is about the advantages and disadvantages of genetic algorithm. So we have already studied the genetic algorithm. We are going to work out with the basics of genetic algorithm, which we have studied till date, right, in the earlier lectures. So first of all, I was telling you in the earlier lecture also that GA is genetic algorithm. And when I say genetic algorithm, so genetic algorithm cycle is mimicking the biological evolution. I have already discussed this particular part, but cycle, which is defined as the reproduction cycle of GA, is this is how it is being defined. First of all, what we are doing, we are having a population, right? When I say population, I mean to say individual chromosome strings, right? So there can be a number of chromosomes, strings of chromosomes, and that can be of 1,000, 100, 10,000, any number, right? So that particular crowd of individual chromosome strings is called as population. Okay. Now, in this population, what we are going to do, we have individual chromosome strings, and those particular chromosome strings are to be decoded. We have already learned the skills how we are going to encode and decode them, right? So we are going to use the decoded strings, and we are going to evaluate the evaluation function. We are going to find out a function which is called as the fitness function. Fitness function. That means the evaluation is based on what? It is based on the fitness function. See here what we call it as, we say that genetic algorithm is what? It is a natural selection which is based on survival of the fittest. Just remember this particular line, survival of the fittest. That means those chromosomes who are defined as the fittest are going to survive in future, right? So that is why we have a fitness function for a particular problem, and according to the fitness function we are going to evaluate these chromosomes. Whichever chromosomes are found to be the fittest, we are going to select them on the basis of certain selection processes which we have defined earlier in the previous slides. That is selection process. We have different types of selection processes such as Rowlett wheel, etc, etc, right? So we select what are we selecting here? We are selecting parents. That means we are selecting two chromosomes who are going to be the parents, and they are going to give birth to the offspring. That means they are responsible to define the new generation, and we want the parents to be the best fittest, so that the offsprings or the new generation that is created is termed as fit and better than the previous generation. So after this selection process, what we are going to apply, we are going to apply the genetic operators. We have studied different types of genetic operators such as crossover operation, then the mutation and bit string, etc, etc, right? We have done all those particular operators. And lastly, what we have the offsprings which are created, and this cycle goes on and goes on till we reach the best solution. And this is how the genetic algorithm is used for optimization, right? So now in this is the cycle of reproduction of GA. You can see this is on the basis of biological evolution. Now, we are going to see it in detail. That is, firstly, what we are going to do, we are going to generate random population of n chromosomes. This n can be any number, right? And n is defined as the population, n chromosomes. Next, we are going to define a fitness function. According to this fitness function, we are going to evaluate each chromosome, and we are going to decide whether the chromosome is fit or not. Next, we are going to define a new population, that is, create new population by repeating certain steps. That means by applying certain genetic operators on these. What are these? First one is called as the selection. Now what we are going to do, we are going to select two parent chromosomes from a population according to their fitness, right? And whichever the one has the better fitness function has a better chance of selection, right? Next operator we apply is crossover operator. We have discussed these in detail in the earlier lectures. You can see that if you want. Crossover, with the crossover probability, crossover the parents to form a new offspring children. If no crossover was performed, offspring is in exact copy of parents. That means what we are doing, we are applying crossover on the chromosomes. When we have two parents, the crossover is being applied. That means we are swapping certain bits from parent 1 to child 2 and parent 2 to child 1, and then we are creating the offsprings, that is child 1 and child 2. Now why we are doing this, we have again discussed this, but again I'm telling you, we are applying crossover operators so that we are not creating the exact copies of the parents, we are creating something new. Next we apply the mutation. This is again another type of genetic operator. In this mutation we are going to flip the bits. Next, we are going to do the accepting, place new offsprings in the new population, right? Next, fourth step is replace. That means use new generated population for a further run of algorithm. Now, all these steps are again repeated and replaced by the new generated population. The earlier generation has been eradicated. Now, from this particular new generation, we are going to repeat the process of selection, crossover, and then again mutation and replacing. Next, fifth step is test. We are going to test if the end condition is satisfied, stop and return the best solution in current population. Else we are going to repeat the loop from second step, right? So let's see this particular in the flow chart form, which we have seen in the text form. That is, we are going to start. We are going to generate initial population of n chromosomes. We are going to calculate fitness function of each individual chromosome. We have a stopping criteria on depending on yes and no. Let's see. If it is yes, we have to end. If it is no, then what we are going to do? We are going to first apply the selection operator, then the crossover operator, then the mutation, then again the fitness function is being checked and the replacing of new generation is being done. And this process, if it is again satisfied, we are going to stop the criteria and end. If it is not being satisfied, then this loop is going to be run again. Right? And what are these? These are the GA operators which are being applied again and again to achieve the best solution. These are the GA operators. Fine. So you have to remember all these GA operators. We have done these particular in earlier lectures. Now, we have certain things which we need to understand of for GA. That is when we are going to use GA. GA is applied for all the problems which are finding the solution for optimization. That is either finding the maximum or finding the minimum. That means the optimization out of a large number of solutions, we can find the best result, which is the best for the problem. So wherever the optimization is needed, we can apply genetic algorithm. Where there are large solutions to the problem, but we have to find the best one. So there we apply the genetic algorithm. Example, we have best moves in chess, mathematical problems, financial problems, etc., etc. Right? In certain, games also, we use the genetic algorithm where the player is just one player and the computer is the second player. Right? Example, playing of the chess, playing of Ludo. That means this particular computer is going to find the best moves and going to learn on its own with the help of neural network technique. Now, what are the advantages of GA? Advantages are: first is parallelism. Second one, traveling in space with more individuals, so they are less likely to get stuck in a local extreme like some other methods. Now, what is this? This is when we are going to define that the solution is not get stuck in local minima, it has to reach to the global minima or maxima, right? This is the disadvantage of certain techniques, but genetic algorithm is going to recover the problem of stucking in the local minima problem, right? Next one is it is easy to implement. Then next, we have some GA, just write new chromosomes to solve another problem. That means genetic algorithm problems can be solved easily, and these can be solved with the help of new chromosomes. Now, same encoding can be done for changing the different fitness functions. That means if we want to apply different fitness functions for different problems, we can apply the same coding. Now, what are the disadvantages? Sometimes the computation time is too much, right? And we can find out that this particular method is comparatively slower than
Slower
other
than some
methods,
other methods.
right?
Choosing encoding and fitness function can be difficult, but with today computers, it is not.
Next, choosing encoding and fitness function can be difficult. Now, the most important part of genetic algorithm is finding out the fitness function. How you are going to choose the fitness function, because for different problems you are going to choose the different fitness function. Now, how to choose this fitness function is again a challenge for the person. So, sometimes choosing the encoding and fitness function can be difficult. But with today's computer, it is not so big problem. So we can apply GA. So these are certain advantages and disadvantages of the genetic algorithm, right? That's all for this. Thank you very much.